The binomial theorem is also useful if you want to find a particular term of an expansion. For instance, find the fourth term of 3x plus 2y to the 7th power. Well, I mean, that'd be a shame if you had to FOIL all that out just to find one term. So, I mean, having this binomial theorem is very useful. So, if it's the fourth term, remember the first term is going to have 7 choose 0, the second term will be 7 choose 1. So, the fourth term is going to be 7 choose 3. And then you'll have 3x to the 4th power and 2y cubed. So if we figure out 7 choose 3, that would be equal to 7 factorial over 3 factorial times 7 minus 3 factorial. So this would be 7 times 6 times 5 times 4 factorial over 3 times 2 times 1 times 4 factorial. 4 factorials cancel. 3 times 2 times 1 is 6. That's 35. So this would, of course, be 35. Now 3x to the 4th would be 81x to the 4th. And then this would be 8y cubed. So if we multiply all that together, we get 22,680 x to the 4th y cubed. Now, there's actually another way to generate these binomial coefficients other than the combinations, and that's what's called Pascal's triangle.
Ms. Zimmerman, if you're in the building.
Silly announcements. So you get Pascal's triangle by adding together the numbers above. So each row starts off with a 1. And then here I take 1 plus 3, that makes 4. 3 plus 3 makes 6. 3 plus 1 is 4, and then a 1. So if you notice, those are actually the binomial coefficients that go with x plus y to the 4th power. So then the next one would be 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1, so on and so forth. So if you wanted to, you could generate all the binomial coefficients you would want from this triangle. So for instance, if we look at the last one I did, this would have been 1, 7, 21, 35, 35, 21, 7, 1. And then the fourth one would have been that one right there. So that would have been the fourth binomial coefficient, which we calculated on this page right here. That'd be this guy. Calculated in this fashion. Just like that. Whoa. Anyway, enough playing around with the magic pen. So that's basically all there is to the binomial theorem. Bye now.